All right, good morning, folks. Thanks for watching my video today on section 3.1. It's about dilations. And I went this summer to visit my sister. She lives in South Dakota and her family. They're really close to Mount Rushmore, maybe 45 minutes away. I'd never been there before. It was so cool. This is huge. This mountain right here is enormous. And the fact that people carve this stuff out, you know, the presidents up here, Washington, Jefferson, Teddy Roosevelt, and Lincoln. So here's the artist. They hired this artist. This is back in like 1929. Borglum was his name. And he had studied in France, all over the world, won some major prizes for being a sculptor. And so he made this, sculpture, and then they scaled it up, right? So like this, I can't remember the scale factor, like 100, I don't know, one inch equaled like 100 feet or something like that. It was ridiculous. So they had this little, I don't know what you'd call it, I can't, they have an official name for it, but like a pole or a stick, and it would protrude out from a certain spot, and they'd measure down the distance to some feature on the president. And then that stick was put in the same place out here, but much larger, of course, 100 times bigger, whatever the scale was. And then they would measure down, and then some miners, there were a lot of local miners that had skills of, putting dynamite in, would blast the rock out and produce these images. Really fascinating. So that's what we're talking about. We're talking about dilations. Here, right over here, this is called the pre-image. The piece that he is working on right there is the pre-image. And then this over here is the image. This is the figure after some kind of dilation has occurred. This is obviously an enlargement because things got larger. So if it got smaller, if we were going the other way for some reason, like he had this and he wanted like a miniature one that they were going to sell in the thrift store, in the souvenir store, whatever you call it, the gift shop. So they were going to make like, a little tiny one that would fit in somebody's pocket. Then it would be called, instead of an enlargement, it would be called a reduction. So they'd be reducing the size, so it'd be called a reduction. And if the scale factor is larger than 1, like in this case, I think it was like 100 times bigger. So the scale factor was 100, let's say. That makes it an enlargement. If the scale factor is less than 1 but greater than 0, then it's a reduction. Like if it's like we're going to cut it like by half, then that's a reduction, right? So let's come back over and we're going to set up some notes right now. So a dilation can be two different things. It can be an enlargement or a reduction. Enlargement or a reduction. All right. And the scale factor is what's going to determine that. So if the enlargement, it's going to be greater than 1, the scale factor. And we quite often use the letter K for scale factor. So I'm going to say if K is greater than 1, then it's an enlargement. If K is between 0 and 1, I'm unhappy with where I wrote my K value right there, my letter K. So I'm going to move that over a little bit. If K is between 0 and 1, okay, so let's say it's like this, then it's a reduction. It's going to get smaller. So they're going to ask these kind of questions. They're going to say, like this figure, let's see, we're going from, this is important right here, from ABC to DEF. So this is the pre-image over here, I'm just going to write pre, and then this is the actual image over here. And so we're going from one side that's 6 long down to a side that's 2 long, and we want to make sure we're matching up the corresponding sides. So you can see AB, this might be real simple because it's all oriented the same way, but AB are the first 2 letters and DE are the first 2 letters. So they're going to match them up like that. So we go like AB to DE. So we'd say, okay, I'm going to take the image. You always take the image divided by the pre-image to get the scale factor. So K is equal to 2 divided by 6, or 1/3 in this case. That's what they're explaining right down here. So let's add that right now. To get the K, you're going to take the image divided by the pre-image. So the pre-image is like where you start, and the image is where you end up. All right. All right. So what is the center of dilation? Well, that's going to come up when we're dealing with points that are being plotted. So let's worry about that in video 2. In class today, we're just going to talk about how to do problems 1 through 5, I think it is. And then I'm going to stop talking in class, and people are going to try problems 1 through 5. And I think you have enough information kind of right now to do 1 through 4. This is what 1 through 4 is like. Number 5 is like this, where you have some kind of banner and they want to enlarge, or they want to make or they want to make a reduction. And so they're talking about percentages, which kind of complicates things a little bit. It says, by what percent should Jalal enlarge his design so that the dimensions of the banner are 5 times that of the original design? So that would mean that you would have a K value of 5. So I would put down K equals 5, but we want to convert that to percent. So we're going to take 5 times 100%, okay? And that would be 500%. So that's the enlargement that they're looking for in this situation. Then it says, what would be the dimensions of his banner? Well, that just means we're going to take 5 times 6, right? So we take times 5 here, so 6 times 5, and we get 30 inches. And then we take 14 times 5, because the scale factor is 5, and that would be 70 inches, I think. And those are our dimensions right now, 30 by 70, 30 by 70, okay? Now, the one that you have to try is about a kid that has a blueprint, and for some reason, he wants to make the blueprint smaller. So it's going to be a reduction. That's what number 5 is talking about. It's talking about one like this, but I'm just going to put down here that it's going to be a reduction because he's trying to get the blueprint to be smaller for some reason. And I hope we can do 1 through 5 on our own now. And then tune back in on video 2, and we're going to talk about the rest of the homework problems. All right. Thanks for watching. Hope you're doing well at home if you're homesick.